Now we can start today's online guest lecture series, lecture second. So today's guest lecture on modern communication system. So I welcome to all participants. First, I welcome to all participants. So good morning. On behalf of Department of Electronics, Sri Shivaji Mahavidyalaya, Barsi, it gives us an immense pleasure to welcome Honorable President of today's second guest lecture, respected Professor Dr. Bhakti Revalkar, Principal of Sri Shivaji Mahavidyalaya, Barsi. I welcome to today's invited speaker, Dr. Mujawar P.H., Assistant Professor, School of Physical Sciences from Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. I welcome to Dr. V.M. Gurme, DBT Coordinator, Professor Dr. T.N. Lokhande, Science Coordinator of this college. I welcome to my colleagues, Professor Dr. K.P. Deshmukh sir, Departmental DBT Coordinator, Sri K.S. Khardekar sir, teachers, participants, and students. I welcome to my colleagues and participants to grace this occasion of the second guest lecture on modern communication system organized by Department of Electronics, Sri Shivaji Mahavidyalaya, Barsi, in association with Department of Biotechnology, Star College Status Scheme. First of all, I am thankful to Dr. Mujawar P.H. for accepting our invitation to deliver guest lecture on modern communication system from her busy schedule. I am quite confident that the guest lecture will provide a very good platform to all the teachers, participants, students to exchange ideas, discuss new trends, challenges, new approach in electronics. The objective of to arrange the guest lecture series and today's second guest lecture on modern communication system is to enrich the current trends in the electronics subject and recent trends in science and technology to motivate the students to pursue better career opportunities in electronics field and industry. The purpose of this guest lecture is to familiarize students with upcoming area in modern communication systems. The importance of modern communication increases over days and years in our life and in our lifestyle. We use modern, developed communication systems, methods in all of our daily activities. None can live without communication. In the present world, communication plays a key role in all the development activities from economic to all relations in national and international activities. I am sure that you will feel enriched with knowledge after completion of this event. I hope her talk may become more informative, motivating, and inspiring to us. So I welcome you all once again to this guest lecture series and hope that you all will have a great time ahead. Thank you all. I hand over to my colleague, Dr. K.P. Deshmukh for so please, K.P. Deshmukh, proceed with the next.
Screen share.
Okay. 1 minute. Okay. So Professor KP Deshmukh, sir. Now,
hello.
Welcome, sir. Dr. KP Deshmukh, sir. I welcome you. Please proceed next.
Okay. All of you can see me?
Okay. Okay.
Okay, sir. Yes. I'm really have a great pleasure that to tell you that Dr. Mujawar, she is a student of our department. She has completed BSc Electronics from Sri Shivaji Mahavidyalaya Barshi, and she completed her post-graduation in the Department of Electronics, Solapur University. And after that, she has also passed SET examination in electronics. She has also completed her PhD in electronics. And now she is pursuing as a lecturer in electronics in Solapur University, Solapur. Okay, I'm very much pleased to tell you that she is the alumni of our department. Okay, and that's a great honor for this department. Yesterday we have seen that the first lecture was on wireless technology and different methodologies which were used in the wireless technology that we are aware of. Okay. Yesterday's lecture was given by Dr. Shirwal. Okay, and he has covered many things related to wireless technology. Today, we have the similar topic, that is a communication system, modern communication system. Okay, and wireless technology is one part of the modern communication system that also we know. So today's lecture will be very much useful to all the students of electronics and all the hobbyists who are interested in the electronics subject. Okay, and that will give you the insight of what is exactly mean by modern communication, what was the old communication system, and what is this new modern communication system. So that also part we are going to cover in this lecture. So I'm really thankful to Dr. Mujawar for accepting our invitation for giving this guest lecture. Okay, so I welcome Dr. Mujawar. I welcome all the participants, okay, who have taken active participation in this seminar. Okay, thank you for the same.
Okay. So thank you, Dr. Deshmukh, sir, giving a nice introduction to today's speaker, Dr. T.H. Mujawar. So I request you, Dr. T.H. Mujawar, please give the talk on modern communication system. So I welcome Dr. T.H. Mujawar. Okay.
Thank you, sir. Thank you, sir.
Thank you.
A very good morning to all of you.
Good
Thank
morning.
you, Professor Dr. Kiran Deshmukh, sir, for kind words of introduction. First of all, I'd like to express my sincere thanks to the principal of this college, Professor Dr. B.D. Rewardkar, ma'am. Am I audible? DBT coordinator, Dr. V.M. Gurame, science coordinator, Professor Dr. T.N. Lokhande, sir, for organizing such a wonderful online guest lecture series. I'm grateful to the HOD, Department of Electronics, Professor Dr. U.R. Ghodke and Professor K.P. Deshmukh sir for giving me this wonderful opportunity to share my ideas and knowledge with you today. In this pandemic situation, as everything goes on virtually, let's start our virtual lecture that is based on modern communication system. May I share my PPT?
Yes, madam. You can share.
Yeah. Sir, my screen is visible?
Yes, madam. It's visible.
Okay. Thank you, sir. The agenda of the today's presentation are introduction, in which we'll see what is wired and the wireless communication. After this, we will see the evolution of modern communication system, in which we'll discuss the generation of communication system starting from first generation up to fifth generation. There are various modern communication system, but among these, in today's lecture, I will focus on cellular telephony. And after this, we'll see the different wireless transmission medias such as IR and radio transmission. Then we will see some advanced communication technologies such as Bluetooth and Wi-Fi. And finally, we'll see one of the promising technology in 21st century, that is wireless sensor network. We will see how actually the implementation of the wireless sensor network has been done. Let's see one by one. Let's see the introduction. Before discussing the modern communication system, first we should have to know what is communication and what are its different types. Let's see what is communication. Communication is the basic process of exchanging the information between sender and receiver. There are different types of the communication such as wired and the wireless communication, and for this it uses different types of the transmission media. Then question arises, what is transmission media? It is a physical path required to transfer the data from one machine to another machine. The transmission media may be wired or wireless. If the transmission media is a wire, then it is also called guided media, and for this it uses cable as a transmission media. Different types of cables are available such as coaxial cable, fiber optics cable, and twisted pair cable. If you talk about the wireless media, then it is also called unguided media, and for their communication it uses radio waves, microwaves, or infrared waves. Let's see why the wireless communication is preferred over the wired communication. If we have to install or establish a large wired network, as I said, for installing the wired network, it requires cable as a transmission media. If you want to install large network, then the large number of cables are required. If the cable increases, then the cabling cost will also increases. This also creates complexity in our system. If suppose the cable within the network breaks, then it collapses all the communication between the network. Therefore, to avoid the incompatibility associated with this wired network or wired communication, here we prefer the wireless communication. Okay. Now let's see the early modes of communication. We know that the humans have been using different methods of communication from the beginning. Let's take a brief overlook over the history of the human communication. The ancient early man used to shout for him to be heard by others far to him. After this, in 200 BC, that is before Christ, the smoke signals were used as a message signal. These signals mostly used in China, and this Chinese guard released the smoke signal into the air, which treated as a message signal to the Great Wall of China. And one of the famous Greek historian, Polybius, used this smoke signal to represent the alphabet. After this, within 500 to 500 BC, the postal systems was developed. Postal system was developed in ancient Persia. With note that with the raising awareness, people started to use the courier services, and the letter were delivered from one person to another person through this postal system. And actually, this system was developed in India, China, or in ancient Persia. After this, in 12th century, the pigeon post was developed in Egypt. Sultan Nuruddin created first pigeon post in Egypt, and British used approximately 3 lakhs carrier pigeons during the Second World War. And pigeons are also well known for their direction, and they are known to find their homes even after traveling the long distances. People used to attach small letters to their necks, hoping they would fly to the receiver. Pigeon also were used by the ancient Romans to tell the owners how their entries had been placed. This pigeon post helped in the evolution of the communication. And after this, in 59 AD, that is in the era of Lord, the newspaper is published in Rome on slab of stone and metal. Actually, the origin of this newspaper is attributed to Julius Caesar. Then in 2000 BC, the courier services was established by Egypt, and in 6000 BC, drums were used as a form of communication in Africa. This drum can travel the messages up to 100 miles per hour. These are the older methods of the communication, which are quite inconvenient and inefficient, and that's why the latest modern communication system developed, which are quite convenient and more efficient. For example, telephones, internet, email, social media, etc. are the mass communication technology. The evolution of communication technology. This evolution made progress. Hello, my voice is audible.
हाँ मैडम थोड़ा ब्रेक व्हायला लागला ना आवाज.
Wait a minute, sir.
विंडोज वगैरे थोडं ओपन करा म्हणजे रेंजचा प्रॉब्लेम आहे बहुत.
Okay. Now it's audible.
No madam.
Now this okay. This evolution will continue to grow so with the changing world. Now let's see actually the evolution of communication system, and in this we'll see the first generation of system, which was actually started in 1980s, which is totally based on analog radio transmission. It uses circuit switch technique, and under this generation different standards has been developed, such as NMT, then total access communication system, then AMPS, that is advanced mobile phone system, and Nippon Telephone and Telegraph. Actually the AMPS systems was primarily used in US and in some Asian countries, while the Japan was the first country in the world to launch a commercial cellular network in 1979, and the name given is TACS, that is Total Access Communication System. After this, NMT was developed or deployed in some Nordic and Asian countries, and NTT is also deployed in Asian countries. Now let's see the specification of these technologies. NMT, that is Nordic Mobile Telephone System, uses FDMA as a multiple access technique, and its speed is up to 1.2 kbps, while the TACS also use FDMA as a multiple access technique, and its data rate or speed is up to 8 kbps, while AMPS also uses FDMA technique, and its speed is about up to 10 kbps, and while NTT's speed is about up to 0.3 kbps. Now let's take a brief overlook over the core network or the communication network of the first generation, which consists of mobile terminal, base station, and mobile switching center, which is given to the another network connected to another network, that is PSTN. This is public switch telephone network. Then let's see what are the drawbacks of this first generation system. Here, you could not use other countries' network. That is, the roaming facilities not provided between the different network. This is the major drawback of this first generation system. And there is a lot of load available on the mobile switching center, and that's why the data rate of this first generation is quite low as compared to other. And to overcome this drawback, the second generation of wireless network has been initiated, which was actually started in the early 1990s, and it uses TDMA or CDMA as a multiple access technology, and it also increases the radio system capacity and spectrum utilization efficiency. The major drawback of the first generation that doesn't support the roaming between the different network was overcome by this second generation, and new design was also introduced in the core network of this second generation. This second generation of this wireless network is fully digital technology. We are also aware that what is digital signal? It is actually consists of ones and zeros, that is high and low bit. Let's see what it comprises. A digital signal consists of low level, high level, rising edge, and the falling edge. Here, when the 0 bit comes under the signal, then it is treated as a low level. When 1 bit occurs in the signal, then it is treated as a high level. When the signal goes from low to high, then it will be treated as a rising edge, and while when the signal goes from high to low, then it is treated as a falling edge of the signal. This is actually the digital signal. Now let's see what is actually the working of the 2G. Here, the digital data can be compressed and multiplexed more effectively than the analog voice encodings. As I said, it uses TDMA or CDMA as access technology. Let's see what is multiple access technology, or what is actually the multiple access. It means that in the multiple technology, the multiple user try to access the channel at the same time, and depending on this, there are different methods such as FDMA, TDMA, and CDMA. Let's see what is FDMA. This is a frequency division multiplexing access or multiple access scheme, in which the bandwidth is divided into number of frequency, and each frequency is assigned to each user. No two users have the same frequency. If the same frequency is given to the user, then there might be a problem of crosstalk or interference. Okay. Now let's see what is TDMA. TDMA is a time division multiplex access scheme, in which the channel is divided into number of time slot, and each time slot is assigned to each user. No two users have the same time slot. Okay. That's why interference problem can be avoided. In case of CDMA, what happened, instead of dividing the channel into the number of frequency of the time, here the code is assigned to each user, and each user have its own orthogonal code. Okay. Now let's see what is actually the core architecture or communication network of the second generation. If we compare this architecture with first generation architecture, here BSC is present, that is base station control, which was absent in the first generation. This BSC reduces a lot of load that is placed on the MSC, and here it also provides the considerable attention which was devoted for the interoperability and standardization in second generation system. Now let's see some of the major standards or the technologies that provided by the 2G. These are GSM, that is Global System for Mobile Communication. It was actually developed in the European countries, that is in a European country, and After this, some of the standards are IS 136, which was initiated in US or deployed in a US, and IS 95. This is a CDMA standard, which was deployed in North and the South America. Now let's see what are the advantage of the 2G. The digital voice encoding allows digital error checking, which increases its sound quality, and also it lowers its the noise level. Going all digital allow for the introduction of digital data transfer, SMS and email that comes under this 2G technology. Now let's see what are the limitation of 2G. If we compare, or if you see the cell towers in the 2G, which had the limited coverage area, and that's why it provides the limited services. These services are mainly focused on the voice services, and its data rate is so quite low, very low, that is up to 9.6 kbps. And now let's see, to overcome the drawback of 2G, the 2.5G wireless network has been initiated. This 2.5G network lies somewhere in between 2G and 3G, and this the development of 2.5G has been built as a stepping stone towards 3G, and was prompted by the demand for the better data services and access to the internet. It also provides faster services than 2G, but not as faster as advanced as the newer 3G system. As the demand increases with the growing mobile users, it also data services, lot of data services provided in the 2.5G network. Its data rate is quite enough as compared to 2G. That is, it is 384 kbps, and the technologies or the standards that comes under the 2.5G are GPRS and H. GPRS stands for General Packet Radio Service, while EDGE stands for Enhanced Data Rates for Global GSM Evolution. And it uses a different path for voice and data transmission. That is, it uses circuit switching technique as well as packet switching technique for voice and data transmission. These are the standards that comes under in it, GPRS and H, and CDMA 1, that is IS 95B standard it provides. This is the communication network of the 2.5G architecture. Here, a lot of advancements are done under the MSC, that is Mobile Switching Center. It includes GMSC or GPRS. PS backbone is also provided in it. And now let's see the third generation, which is actually developed to give real-time voice or real-time streaming or non-real-time video. It is totally provides IP-based data and voice and multimedia. 3G, it provides larger capacity. Hello, sir. It has large capacity and provides a broadband capacity. It allows the transmission of 384 kbps, and its transmission rate is increased up to 2 Mbps. It provides increased spectrum efficiency up to 5 MHz. It means that the greater number of users that can be simultaneously supported by radio frequency bandwidth, and it has a higher data rate at lower incremental cost than 2G, and it supports 3G technology generation uses CDMA as a multiple access technology, and it doesn't divide the channel by time or frequency. Instead of that, it encodes data with a special code associated with each channel. Here you have shown that each user have its own data, that is green code is provided. Some of the user uses purple code in CDMA. It means the CDMA users are separated by their orthogonal codes, and for this it uses pseudo-random numbers. Now let's see what actually the fourth generation system. This is a fully wireless and fully digital communication technology, and that uses LTE as a standard, that is long-term evolution standard for high-speed data up to 200 Mbps. This standard was actually initiated by NTT Docomo in 2004, and 4G is also organized by 3GPP, that is a third generation partnership project. And instead of using FDMA, TDMA, or CDMA, this fourth generation system uses OFDM as a multiple access technology, that is orthogonal frequency division multiplexing technology. It uses. Now let's see how the technology is moving towards 4G. If we let's see here how the technology is moving from low speed to high speed. It means in 1995, the first generation of the system, communication system, has been developed, which is fully analog technique. And after this, in 2000, digital based technique has been developed, which is 2G. And in 2005, then the technology is moving towards 3G technology, and having a data rate of up to 384 kbps. And in 2010, actually the 4G system has been developed, which is having a data rate of up to 100 mbps, and it uses different wireless standards such as WiMAX or Vibro. The features of 4Gs are it is more faster and more reliable as compared to other generation. Its data rate is up to 100 mbps, and it has a lower cost than the previous generation. And it uses multi-standard wireless systems such as Bluetooth, wired, or wireless. Okay, and it supports the ad hoc networking. Here, the ad hoc networking means that the two users can communicate directly with each other without any access point. Here in 4G, OFDM is used instead of CDMA, and its IEEE standard is 802.11n. If we compare 3G with 4G, we observe that 3G uses the frequency band of 1.8 to 2.5 gigahertz, while the 4G uses the frequency band of 2 to 8 gigahertz. It uses the bandwidth up to 5 to 20 megahertz. The data rate of 3G is up to 2 Mbps, while the 4G is from 100 Mbps, and its data rate is currently it increases up to 1 Gbps. It uses 4G uses the packet switching technique, while the 3G uses circuit or packet switching technique for voice and data transmission. Here also, 4G system provides an end-to-end IP solutions where voice and data stream multimedia can be served to user on any time, anywhere basis at higher data rate than the previous generation. It provides higher security, and for providing the higher security, it uses advanced encryption and decryption algorithm. And for this, it uses public or the private keys for this, and it offers any kind of services like anytime, anywhere, and it has affordable cost than the previous generations. These are the specification of this fourth generation system. Now let's see what is actually the fifth generation system. It is a very fast mobile network technology over the dense urban areas with as a multiple access technology, that is dynamic spectrum access, which allows secondary users to access abundant spectrum holes in licensed spectrum band. This is a fully license free band, and it is coordinated actually with the fiber wireless network that uses the band of 20 to 60 gigahertz in order to allow a very wide bandwidth. They supports the data rate of up to 10 Gbps. It also offers a short wireless links like Wi-Fi with local fiber optic terminals rather than long-range cellular services. Now let's see how the evolution of 5G has been taken place. Here in 1979, introduction of first G was done, which uses analog telecommunication. In 1991, 2G services are provided, which offers text messaging. In 1998, 3G has been initiated, which supports mobile and wireless internet connection, while in 2008, 4G services has been initiated, which supports cloud computing, IP, and truly a mobile broadband services with provides, which has a quite enough data rate as compared to the previous generations. And actually in 2099 the launch of 5G has been taken place, which which has unlimited data capacity than the previous generation. In this way we'll see the evolution of the communication technology starting from the first generation up to fifth generation. Now let's see one of the advanced communication system. There are different modern communication technologies or communications such as satellite communication, mobile communication, radar communication, etc., or computer networking communication. But in today's lecture we'll see mainly focus on the cellular system. And in case of cellular system, cell is the heart of the cellular system. Let's see what is actually the cell. It is called a base station that covers a certain area. Here the area of a cell are different or vary from tens of meters in a buildings and hundreds of meters in a cities and up to tens of kilometers in a countryside. Different types of the cells are available, such as femtocell, picocell, microcell, or the megacell. If you talk about the femtocell, then its coverage area is too small, and the best example of a femtocell is infrared transmission. If we talk about picocell, then its coverage area is large as compared to the femtocell, and this example is Bluetooth. If we consider the microcell, then Wi-Fi or wireless LAN is the best example, which are having a quite large coverage area than the femtocell and the picocell. And if you talk about the megacell, then satellite communication is the best example because it globally cover all the users. Now let's see, the shape of the cell are never perfect. It may be triangular in a shape or a circular in a shape or hexagon in a shape. Mostly for the cellular communication or the or mobile communication, hexagon type of cell is used. Let's see in the next slide. Why cells are hexagonal? Because the hexagon is the closest approximation to a circle, and by using this hexagon type of the cell, the theoretical calculation of the several cellular systems can be made possible. Calculations such as calculation of diameter of a cell, radius of a cell, or frequency planning, etc. All the several system parameters can be made so much easier by using hexagon type of cell. Okay, now in the center of the cell, hexagon type of the cell, the omnidirectional antenna is used, which covers the users in all the direction. That's why mostly cells are hexagon shape. Okay, now let's see some of the basic terminologies in cellular concept, such as base station, voice channel, and the control channel. What is base station? It is a fixed station in a mobile radio system that is used for radio communication with mobile station. There are two different channels are available in cellular system, that is voice channel and the control channel. Here the voice channel is used for voice communication, while the control channel is used for call setup, call request, and it is related to call handling processes only. Now let's see one of the most important concept in the cellular system, that is frequency use. First, see what is frequency planning. It is actually the design process of selecting and allocating a channel groups for all of the cellular base station within a system. If one transmitter is far away from the another, that is outside the interference range, then it can use the same frequency. Let's see the frequency use concept in detail. This concept is mostly based on the ISM band, or it uses ISM band. This is industrial scientific medical band. It is totally license-free frequency band having a bandwidth of 2.4 gigahertz. As I said, cell is the large geographical area. Here, the large cell is divided into number of cells, and that process is called cell splitting. And the group of cell is called cluster. In this diagram, 3 clusters have shown having the different frequency, which has been represented by the letters A, B, C, D, E, etc. purpose, while in the second cluster, the same frequency A is used for the medical purpose, and in the third cluster, the same frequency A is used for the scientific purpose. But condition for this is that no two cells having the same frequency are put adjacent to each other. If we put the cell having the same frequency are put close to each other, then it creates interference problem or crosstalk problem. Okay, that's why the cells having the same frequencies are placed apart from each other. Okay, this is the frequency use concept. It means the license of frequency band frequency we have to use again and again. Okay, now let's see what is actually the advantages of the cellular system. It provides the larger capacity, and it provides larger capacity. It covers the maximum number of users. If you talk about its disadvantage, then for this, lot of frequency plannings are required. More infrastructures are needed for this. If suppose instead of using the large cell, if you divide, instead of using this small cell, if you use a large cell, then what are its drawbacks? In case of a large cell, if you put the senders and receivers there, as the distance between the senders and receiver increases, due to the large distance, there is might be a possibility of noise within them, and therefore a lot of frequency plannings are needed there. More infrastructures are needed. That's why we divide the large cell into the small cells. Okay. Now let's see the actual another concept in the cellular system, which is handoff. When the user moves to another base station, then the switching of frequency from one cell to another cell, and that switching of frequency handoff. Basically, there are two types of handoff, one handoff and another is hard handoff. Let's see one by one. What is soft handoff? Another name for this is make before break. It means that before entering into the second cell, first accept the range of the second cell, and then only release the range of first cell. Okay, that's why there is no possibility of call loss or call degradation cannot be happen. If you talk about the hard handoff, the another name for this is break before make. It means that before accepting the range of the second cell, first release the range of first cell. That's why there is a possibility of call loss or call degradation can be happen here. Due to this, soft handoff is preferred over the hard handoff. Sir, my voice is clear? Deshmukh sir.
Yes, madam. It's clear.
Okay. Now let's see some of another advantage of cellular system. As I said, it provides the higher capacity or less transmission power is required for this, or it supports only the local interference, and it is totally a robust technology. It means that if one of the cell within the cluster breaks, it doesn't affect the another cell. The whole communication between the entire cell or cluster goes on smoothly. That's why it is a robust technology. Now let's see what are its disadvantages. More infrastructures are needed in cellular system, and hover is needed, or the frequency planning is needed here. Okay, now let's see the transmission medias of the wireless communication. In this we'll discuss firstly the IR transmission. What is IR? It is actually the infrared technology that uses diffuse light reflected at a wall, furniture, or it uses a direct light if a line of sight exists between sender and receiver. What is line of sight? It means before sending the data from sender to receiver, here the sender and receiver should be visible to each other. Then we can only send the data. Otherwise, it's not possible. Let's see what are its advantage. It is a simple and extremely cheap technology. The laptops, mobile phones have an infrared data association interface. Before introducing Bluetooth into our mobile, there is a facility of IRDA. But we have to install IRDF facility in our mobile phones for sharing of files. But here the coverage area of this technology is too small. That's why for while sending the data from one mobile phone to another mobile phone, we should have to place the two mobile phones very close to each other. Okay, and if you install the version 1.10 into our mobile, then it supports the data rate of up to 115 kbps, while the version 1.1 of IRDA supports the data rate of up to 4 mbps. This is the maximum data rate of this IR transmission, which is quite enough data. Okay, what are its disadvantages? It provides the lower bandwidth as compared to the other LAN technologies. Here, the 4 Mbps is not a particular high data rate. The infrared transmission cannot penetrate through any type of obstacle. The obstacle may be walls, furniture, etc. An example of the IR transmission is TV and remote control is the best example of IR transmission. And for typically for the good transmission quality and in order to provide the higher data rate, line of sight is required in between sender and receiver. This is the major drawbacks of IR transmission. And to overcome these drawbacks, new transmission media is developed, that is radio transmission. If we compare this radio transmission with the infrared transmission, we observe that this radio transmission having higher bandwidth as compared to this transmission, and it provides the data rate of up to 100 Mbps. And in the current year, this data rate is improved, and or in terms of Gbps, and it can penetrate through any type of obstacle. Or for a good transmission quality, this radio transmission doesn't require any line of sight of communication between sender and receiver. All the mobile phones uses radio as a transmission media for file sharing or any type of application within it. Okay, now let's see some another advanced technology such as Bluetooth. It is a method for data communication that uses short range radio links in order to replace the cables between the computers and their connected units. It is fully a wireless technology, and it is a cable replacement technology. Actually, it is quite inexpensive, and it is also operate on a ISM band having a bandwidth of 2.4 gigahertz. And this Bluetooth uses two different types of the network architecture, such as Piconet and Scatternet. By using Piconet architecture, you can connect up to 8 devices simultaneously, and by using Scatternet architecture of a Bluetooth, you can connect more than 8 devices. Okay, now let's see the maximum distance or operating area of the Bluetooth is 10 meter. To overcome this drawback, the Wi-Fi is invented. What is Wi-Fi? It is actually a wireless fidelity wireless technology that uses a radio frequency in order to transmit the data through the air. Wi-Fi is an alternative to the technology which is commonly used for connecting the devices in wireless using radio waves. Let's see how actually the Wi-Fi works. This technology uses radio signals to transmit the data, just like our old radio sets, TVs, and walkie-talkies. It uses the wireless adapter of the device that translate the digital data to the radio signal. After this, these signals are then transmitted over the antenna routers, and finally the router receives the signal and it decodes them. Okay, in this way this Wi-Fi works. Now let's see what are its advantages. It is truly a wireless networking solution which is very fast, easy, and its deployment of Wi-Fi is very easy as compared to other. Why it is a wireless networking system that is secure, easy to manage, and built to go with you. Its installation is very quick, and it provides easy setup, and it has fast data transfer rates as compared to Bluetooth. And then let's see what is the limitation of Wi-Fi. The first drawback or its limitation is it provides the limited range. It has a data security risk Okay, then interference from other devices is possible in case of Wi-Fi while using the Wi-Fi, such as interference from telephones or microwave ovens. It requires high power consumption and making battery life and heat a concern in the Wi-Fi. Okay, if we compare this Wi-Fi or Bluetooth, then we observe that Bluetooth uses the bandwidth, provides the data 800 kbps. This bandwidth is very low in case of a Bluetooth. In case of Wi-Fi, it provides high bandwidth, having a data rate of 11 Mbps. It's the cost of Bluetooth is very low as compared to Wi-Fi. The power consumption of Bluetooth is low as compared to Wi-Fi, and both uses the bandwidth of 2.4 gigahertz. This is a license-free frequency band, and it is also called ISM band. If we compare the security of Bluetooth over Wi-Fi, it observed that the Bluetooth is less secure as compared to Wi-Fi. In its operating area of a Bluetooth is 10 meter, while the Wi-Fi, its operating area is 100 meter. Bluetooth is used to connect up to 7 devices at a time, and it is easy to switch between devices or find and connect to any devices. While in case of Wi-Fi, it is more complex and requires configuration of hardware and software. Okay, here we have seen the different communication technologies, starting from cellular system, then Bluetooth and Wi-Fi. After this, a lot of advancements have been done in the communication technologies. Now let's see one of the technology in the 21st century, that is wireless network. Before discussing this wireless sensor network, first we should have to know what is network. Here, the network is a group of devices which are interconnected together in order to share data from one machine to another machine. Let's see what is actually the sensor network. Sensor network is a network that comprises of sensors, controller, and many computing units, that is in order to observe, recognize a particular event or the phenomena. If such a network uses a wireless protocol for their communication, and after this, the network which is developed is called wireless sensor network. This network coordination among the physical world and the internet globe. Wireless sensor network is actually the network of sensors and actuators which is used to collect the data within the environment without any infrastructure network. Okay. Basically, this wireless sensor network is used for monitoring and controlling of physical world by using computing units, controlling units, and to do this, it uses sensor node. Here, actually, the sensor node is the fundamental unit of the wireless sensor network. Okay, now let's see the general architecture of a wireless sensor network. In this architecture, here the sensor nodes are randomly deployed within the sensor field. These sensor nodes are interconnected together through the wireless link. The function of the sensor node is to collect the data within the environment and give it to the gateway node. Here, the gateway node acts as a base station, which takes the data from the sensor node and give it to the internet, because the user is directly connected to the internet here. Okay. Now let's see what are the different types of the network types of the wireless sensor network. As I said, the sensor nodes are randomly deployed within the sensor field. Depending upon the deployment of the sensor node, basically there are two types of the network. One is the unstructured wireless sensor network, and another is structured wireless sensor network. Okay, if you talk about the unstructured wireless sensor network, it consists of few number of sensor nodes which are randomly deployed within the network in ad hoc fashion. Okay, it means the sensor node are deployed within the environment without any careful planning. And for this, large network maintenance and management cost is required in case of unstructured wireless sensor network. If you talk about structured wireless sensor network, in this the sensor network or sensor nodes are deployed within the environment in a pre-planned manner. Okay, the sensor nodes are deployed at a specific area within the specific area in order to cover a particular area. Okay, that's why it requires lower network maintenance, and its management cost is low as compared to unstructured wireless sensor network. Due to this, here the structured WSN is preferred over the unstructured WSN. Now let's see the brief overlook over the infrastructure mode and ad hoc mode. If you consider the infrastructure mode here, the node to sensor nodes or the node to users can communicate directly to each other. They can communicate via the access point, while in case of the ad hoc mode, the two sensor node or the two users can communicate directly because the access point is absent here. Okay. Now let's see why the wireless sensor network is preferred over the other advanced communication technology or other network. Okay, now let's see. As I said, to avoid the incompatibility that is associated with the wired network, here the wireless sensor network is used. The advantage of this wireless transmission is a significant reduction and simplification in a wiring. Sorry, and harnessing of the communication range signal. By using this wireless sensor network, any impossible sensor applications can be done so easily. If you want to monitor a dangerous, hazardous, or unwired, or at a remote area in the location, then we can done it easily by using this network. This network also provides unlimited installation and flexibility for sensor and increased network robustness. Okay, with wireless technology also reduces the maintenance cost or the mainly the network management costs of the network. And the sensor node which has used in the wireless sensor network are having self-diagnosing capabilities or self-organizing capabilities. That's why we can develop any type of application very easily by using wireless sensor network. Okay, that's why the wireless sensor network has been used in many real-time applications, and this miniaturized sensor can sense, process, and communicate very easily as compared to other advanced communication technology. Now let's see what are actually the elements of the wireless sensor network. Basically, the wireless sensor networks are divided into two, that is in a sensor node and the network architecture. Let's see one by one. What is the sensor node? Sensor node is actually the fundamental unit of the wireless sensor network, which is made up of from the four subsystems, that is sensing subsystem, computing subsystem, communication subsystem, and the power supply subsystem. Let's see one by one. What is sensing subsystem? In case of a sensing subsystem, it uses sensor. We know that what is sensor? Sensor is a device that converts one form of energy into the another form. Okay, or it converts any physical quantity into the electrical quantity. The physical quantity may be temperature, pressure, humidity, etc. While the electrical quantity may be any continuously varying signal such as voltage or current. Depending on the application, we can use different type of the sensor in our application. Now let's see what is actually the computing subsystem. For the computing subsystem, it uses microprocessor or the microcontroller. If you want to take any logical decision regarding the application, then we require the microcontroller. Basically, the microcontrollers are operates in the four modes, that is active mode, off mode, active mode, off mode, and on mode, or ideal mode. In case of the active mode, both the CPU and its internal peripherals are in on state, while in case of the ideal mode, is a CPU and its internal peripherals are in a off state. They can be turned on by providing external interrupt to them in order to develop some energy efficient wireless sensor node. Then basically the microcontrollers operates in the ideal mode. Okay, Now let's see the communication subsystem for the wireless sensor network. As it requires the wireless communication, basically radios are used for the wireless communication. Different types of the radio protocols are available in the market, such as Zigbee, Bluetooth, UWB, that is ultra wide band, and depending on the application you can use different wireless protocol. Basically radios are also operate in the 4 mode, such as receive mode, transmit mode, ideal mode, and the standby mode. If you want to transmit the data from the radio, then operates in the transmit mode. If you if you want to receive the data from the radio, then operates in the receive mode. It observed that in case of the ideal mode, the radio consumes same amount of power as in the receive mode. Okay, in order to develop the energy efficient sensor node, basically the radios are kept in a ideal mode. Okay, now the fourth subsystem is a power supply subsystem. This is the most important subsystem of the wireless sensor network because it provides power to the sensor node, and for this it requires the battery as shown in the diagram. Okay, as shown in the diagram, battery, because this battery provides the power to all the sensor node. Okay, here the lifetime of the sensor node is depend upon the life of the battery, and lifetime of the whole network is depends upon the lifetime of the sensor node. That's why this power supply subsystem plays very important role in the among all the subsystem. Okay, now let's see some of the characteristics of the sensor node. It is first characteristic is the fault tolerance. It is the capability to maintain the sensor network functionalities without any break due to the sensor node. Okay, network, and for this it uses large number of sensor nodes, and if one of the sensor node within this network get breaks or something wrong happen within it, then it doesn't affect the entire network. The communication between the other sensor node goes on smoothly. Okay, now the another characteristics is mobility or mobility of nodes. By using the characteristics, the nodes can move anywhere within the sensor field based on the type of the applications. Then the third characteristics is dynamic network topology. First, we should have to know what is topology. The topology means how the sensor node within the sensor network is laid out. Means how the it defines the position of the sensor node within the network. Depending on this, there are three types of the topologies, as tree topology, mesh topology, and the star topology. As we develop the number of applications by using WSN, that's why, and depending on the application, you can use different types of the topology, and this WSN should have the capability to work in the dynamic topology. Okay, now another characteristic is the communication failures. If any node in the WSN fails to exchange data with other nodes, then it should be informed without delay to the base station or the gateway node. The another characteristic is the scalability. By using these characteristics, we can define the how many number of sensor nodes are used by the wireless sensor network. Okay, basically the number of sensor nodes in a sensor network can be in the order of hundreds or even thousand. Hence, the WSN design for the network is supposed to be highly scalable. If more number of sensor nodes are used within the network, the network should be highly scalable, considered as a highly scalable network. Okay. Sorry. The another characteristics is independency. In this characteristic, by using this characteristic, the WSN should have the capability to work without any central control point. Okay. Then the next characteristic is the utilization of a sensor. It means the sensor should be utilized in a way that it produces the maximum performance with less energy. Now the another characteristics is a cluster head. It is actually the one of the sensor node which is used to perform the data fusion and data aggregation functions in the WSN. Actually, the fusion function, if it can by using this function, the WSN network can overcome the restriction of the energy and the bandwidth. And what is data aggregation functions? By using these functions, we can improve the network lifetime and the energy efficient node we can develop by using these functions. Okay, this cluster head is also operates on the ISM band, having a bandwidth of 2.4 gigahertz. Now the another node is a gateway node. It is actually one of the sensor node. If we compare this gateway node with the other sensor node and the cluster head, then it is most powerful in terms of the program and the data memory, which is also operates on the ISM band, having a bandwidth of 2.4 gigahertz of a radio frequency. And the final characteristics is a base station, which is an extraordinary type of the nodes having high computational energy and processing capability. Okay, these are the characteristics of the sensor node. Now let's see what is actually the network architecture of the WSN. When a large number of sensor nodes are deployed in a large area to cooperatively monitor a physical environment, then the networking of the sensor node is equally important. And depending on this, there are two types of the architecture. One is single hop architecture and another is a multi-hop architecture. If you talk about the single hop architecture, here the base station is directly connected to the sensor node. If we see the multi-hop architecture, here instead of connecting sensor node directly to the base station, they are connected through two or more intermediate node. Okay, the main difference between this single hop and the multi-hop architecture is the number of hops a packet takes to reach the final destination. Then the question arises, what is hop? It is actually the number of the different network a packet has to go through in order to reach its final destination address. Okay, in case of the single hop network, when a packet leaves the source, it just takes a single hop. Okay, it means it can go through another network, or you can say it passes through another router from a different network before reaching its final destination address. Okay, it just takes a single hop. If we consider the multi-hop network, in this network a packet has to go through two or more different networks in order to reach its final destination address. While taking a hop through a different network, a packet may go through the various devices like routers, network bridges, or switches, etc. Now let's see how the WSN networks are organized. If we compare this WSN model with the OSI model of the computer network, it is observed that the OSI model is a 7-layered architecture, while the WSN model is a 5-layered architecture. In WSN model, the session and the presentation layers are absent, which was present in the OSI model. Here it uses 5 layers: physical layer, data link layer, network layer, transport layer, application layer. Each layer works independently here, and each layer provides the services to the layer above and below it. As the functioning of each layer or the language of each layer is different, then how they can communicate with each other, in order to provide the communication between the two different layers, we should have to match the WSN stack of the each layer. Okay, now let's see the functioning of each layer one by one. The bottom layer of the WSN layered architecture is a physical layer, and here the data is available is in the form of bit. The networking device which it uses is a repeater. Okay, and it is this layer is basically responsible for the frequency selection, modulation, and the data encoding. Okay, the another layer is the data link layer, which accept the services from the physical layer and give it to the network layer, and vice versa. And it provides the functions as a pathway for multiplexing of a data streams, data frame detection, medium access control, and the error control. The major or the important function of these layers are error control and the flow control. If we compare or if we consider the error control, suppose while sending the data from sender to receiver, if one of the error occurs between them, then by using error detection and the error correction, here in the data link layer, this error can be detected, find out, and corrected, and finally the data is received to the receiver. And to do this, it uses different types of the codes, that is Hamming code and the CRC code, that is cyclic redundancy code for this. If we consider the flow control function of this data link layer, this flow control, if suppose if you want to send the data sender to receive, sending speed is high while the receiving speed is slow. Sender continuously send the data to the receiver, then a lot of data might be arises at the receiver side, which that is flooding of data actually takes place at the receiver side, which creates the network congestion problem or bottleneck problem at the receiver side. That's why there is a possibility of loss of data. Therefore, to avoid this problem, the flow control should be provided between the sender and receiver. Actually means synchronization is provided between sender and receiver. Before sending the data from the sender and receiver, first we should have to match the speed of both sender and receiver. Okay, then there is no possibility of loss of data in between sender and receiver. This is actually the functioning of the data link layer. Okay, now the third layer is the network layer, which accept the services from the data link layer and give it to the transport layer, and vice versa. This network layer here, the data is available in the form of the packet, and the networking device it uses is a router. Router is a device which provides the shortest path among the communication, and the main function of this layer is to route the data supplied by the transport layer using special multi-hop wireless routing protocol between a sensor node and the gateway node. Okay. The next layer is a transport layer, which accept the services from the network layer and they give it to the application layer, and vice versa. Okay, here the data is available is in the form of the segment, and the networking device that uses by the transport layer are bridges or the gateways. Okay, and basically it is used to maintain the flow of a data if the application layer requires it, and it uses different types of the protocol for their communication, such as TCP and UDP, that is transmission control protocol, or maybe user datagram protocol in it. Okay, now the topmost layer of the WSN model is the application layer. It is totally a user friendly layer, and it makes the hardware and software of the lower layers transparent to the user application. Okay, it contains lot of protocols regarding the user application. This is in this way the WSN networks are organized. Now see the challenges faced by the wireless sensor network. Okay, here the sensor networks do not fit into any regular topology, because while deploying the sensor node, they are scattered everywhere. That's why they do not fit into any topology. Okay, and it provides very limited resources. It comprises a limited memory, it has a limited computation, limited power it requires, and to work on this limited power, it itself a big challenge of the WSN network. Okay, it supports unreliable communication. There is a lot of conflicts and latency problem, and that creates a lot of challenging task by the WSN network. Okay, the sensor nodes actually relies on the battery, and when we install the WSN network in unattended environment or in uncovered area, then in this case, suppose if the battery replacement is not possible, then it creates a lot of problem. Okay, then hardware design for the sensor node should also be considered. It itself a big challenge, and by providing the synchronization between the two different nodes is also another issue. And node failures, topology changes, adding and deletion of the nodes is another big challenges faced by the wireless sensor network. If we consider the another challenges of the wireless sensor network, such as energy, self-management, wireless networking, and security, these are the big challenges faced by the wireless sensor network. If we talk about energy, then we know that for working of the wireless sensor network, we use sensor node, and for working of this sensor node, battery plays a very important role. As I said, when we install the WSN network in unattended environment or in uncovered area, suppose in this case the battery replacement is not possible, and to work on the this battery or the energy, or to provide the energy to the wireless sensor network is itself a big challenging task. Okay. Then self-management. When the nodes are deployed in uncovered area, and if suppose one of the node within the network get breaks due to the property of this self-management of the sensor node, and they can they get self-manageable with each other, and to develop or to provide the self-management to the sensor node, it itself is also a big challenge. Okay, now let's see the wireless networking. Obviously, the wireless sensor network uses the wireless communication, and regarding the wireless communication, there are a lot of range problem, near far problems, or attenuation problems may be created, and to work on it, it itself another big issue of the WSN network. Okay, and finally, the security of the wireless sensor network. The sensor node sensor node provides the very much confidential data regarding the application of the network, and to provide the very much security to the sensor node, different types of the encryption algorithms has been used, and to develop this encryption algorithm, a lot of backpropagation algorithms we have to use, and for this it uses many public and the private keys. Okay, it means the security is itself a big challenge of the wireless sensor network. These are the challenges that faced by the wireless sensor network. Now let's see the opportunity that comes under the wireless sensor network. Here, the research and the commercial interest in the era of the area of the wireless sensor networks are growing exponentially, which is manifested in many ways. The number of web page which has been developed for the sensor networks are 26,000 hits, and for the wireless sensor network in August 2003, the number of web pages developed are 8,000, which has been increased in the current years. Then the increasing number of annual workshops such as IPSN, then SNPA, WSNA, that is wireless sensor network and the application, which creates the lot of opportunity under the wireless sensor network area. Then the conference sessions on sensor networks in the communication and the mobile computing committees might create the opportunity in WSN. Then various projects that provided by the various funding agencies such as UGS, that is unattended ground sensors, DST, okay, then DARPA, etc. may provides a lot of projects, funds to the projects regarding the wireless sensor network, which creates the opportunity in the WSN. Okay. Then Business 2.0 lists the sensor robots as one of the 6 technologies that will change the world, while the technology review at MIT and Global Future identifies that WSN becomes considered as 10 emerging technologies that will change the whole world. Okay, this might create a lot of opportunities in WSN, and the combination of the sensor network technology with MEMS and nanotechnology will greatly reduce the size of the nodes and enhance the capabilities of the network. These are the opportunity that comes under the wireless sensor network. Now let's see the applications that we can develop by using wireless sensor network are basically divided into 3 categories. That is monitoring of the object, monitoring of an area, then monitoring of both area and objects. If we see the monitoring of object, different types of application we can develop under in it, such as environmental and habitat monitoring, precision agriculture, indoor climate control, military surveillance, intelligent alarms, etc. If we compare if we consider one of the applications such as precision agriculture, it plays very important role in a drought-prone area, because where the water management is very essential, and to develop the smart precision agriculture system by using WSN is itself lot of in WSN, such as if we develop the WSN network in agriculture, then it collect the sensor within this environment, it collect is used to evaluate, optimize sowing densities, estimate fertilizers and other input needs, and to more accurately predict crop yields. Okay, this precision agriculture provides cultural operation more efficient, and it reduces the environmental impact. Okay. Now let's see the another category, that is monitoring object. Under this, the different applications are come, such as structural monitoring, ecopsychology, condition-based maintenance, medical diagnostics, and urban terrain mapping. If we consider one of the application, that is condition-based maintenance, in this under this application we design Intel fabrication plants. In this, the sensor which I have used in this networks collect the vibration data, monitors wear and tear, and reports the data in real time. This system or this network actually reduces the need for a team of engineers, cutting costs by several orders of the magnitude. Okay. If we consider the third category of the applications of the WSN network, that is monitoring interactions between objects and space, the applications which are come under in it are wildlife habitats, disaster management, emergency response, asset tracking, healthcare, manufacturing process flows, etc. The applications can be developed. Consider one of the application, that is habitat monitoring. Under this application, one of the applications is developed in Kenya in order to monitor the zebra movement, and for this it uses Scholar mounted sensor, and this project is totally called as Zebra Net project. These are the some glimpses of this network. Sorry. Then let's see the future of the WSN network. By using this WSN network, we can develop the smart home system or the smart office system. In this category, in case of the developing the smart home system using the WSN, where the different number of sensors or different number of sensor nodes are deployed within the home in order to monitor or control the electrical appliances or electrical devices within the home. Or in case of the smart office, the better lighting and the heating is provided in the office buildings. The Pentagon building mostly use these sensors extensively. Okay. In case of the biomedical applications, this WSN, by using the WSN network, we can monitor the patient's health remotely. So my voice is clear? Hello?
Yes, yes, it's clear.
Sir? Yeah.
Yes, it is clear.
Can monitor the patient's health. Okay, sir, thank you. We can monitor the patient's health continuously. We can monitor the patient's heart rate, glucose, or cancer detection makes easily by using this WSN network. And by using this, we can monitor the patient's vital signs and record anomalies in the patients very easily. In case of the military application, it provides this WSN network creates evolution in this military applications, such as in the military application, there is actually always a threat of being attacked by enemies. So the use of this network, this network help to reduce the losses within the military application, or provide a suitable sensor system that can identify and classify the threat that based on the count, number, and type, whether it's vehicle or men in the food, or the type and the amount of weapons, etc., can be determined very easily by using the number of sensors that deploy within the sensor node in the military campus. Okay, this system provides the reliable real-time war and war picture and better situational awareness that by using the WSN network within the military applications. A remote deployment of this sensor for the tactical monitoring of the enemy troop movements is possible easily by using WSN network in the military applications. If we talk about industrial and commercial application, then numerous industrial and commercial application has been developed by using WSN, such as we can agricultural crop conditions, in process parts tracking, RFID theft, customer tracing, etc. application can be developed by using WSN network. And it is if we compare this wireless sensor network based industrial application with the traditional wired device conditioning and monitoring application, then it is observed that it is WSN based industrial applications are having a relatively low cost and convenience of installation and relocation, and by replacing the periodic manual checkups with the continuous wireless monitoring, it is claimed that industries could save up to 80% of the energy consumed by the motor system. So the industrial monitoring system based on the wireless sensor network have many potential advantages over the traditional wired industrial applications. Okay. Then let's see the traffic management and the monitoring application. When we install, if you want to develop the smart parking solutions or the smart traffic management system using wireless sensor network, then this system can monitor the traffic flows very easily, and it provides the real-time route updates. And also the future cars could use wireless sensor in order to handle the accidents or to handle the thefts. These are the human application which has been developed by the wireless sensor network. Now let's see the brief or look of the wireless protocol is used by the wireless network. Different types of wireless protocol it uses, but in today's lecture we focus only on the MAC protocol. What is MAC? That is the medium access control protocol. This protocol is required when multiple users try to access the at the same time. Then it is very difficult or challenging task. The priority is given to the which user, and this can be done by using this protocol. And for this, it uses number of sub protocols such as CSM. Hello.
हॅलो
Hello. हाँ सर.
बहुतेक हे तुमचं बँडविड्थचा प्रॉब्लेम आहे थोडा. तुम्ही परत स्क्रीन शेअर.
Okay, sir.
हा.
My screen is visible, sir.
नाही अजून. ओम ठाकूर. Yes. It is visible.
Now it's visible.
Yes. Please share it now.
Okay, sir. If we then it uses carrier. If we compare this MAC protocol, it uses different sub protocols such as CSMA. So what is CSMA? That is the.
Your video is visible.
Okay, sir.
Please share.
Okay, sir. Wait a minute, sir. Poor net connectivity. This problem arises, sir, due to this. Wait a minute. Oh my God. What's the problem arises? Okay. Now, sir, screen is visible.
But please share your PPT, PowerPoint presentation.
Now,
It is showing the Zoom window.
okay, sir. Instead of sharing my PPT, I have.
Yes. It is available now. Yeah. We can see the screen.
Wireless.
Yes, we now can.
For this, it uses different types of the wireless protocol it uses, and basically wireless sensor network uses Zigbee as a protocol while installing the wireless network. And why the Zigbees are used mostly as compared to other protocol? Because it has a low power consumption and it has low cost of device, its installation and its maintenance is also very easily. It is a simple and user friendly protocol. Okay, that's why it is used more as compared to other. There are basically two types of architectures of the Zigbee. One is the Zigbee series 1 and another is a Zigbee series 2. Both the series 1 and 2 were developed by the microchips, and it provides point communication. But here the Zigbee series 1 is called Zigbee, and while the Zigbee series 2 is called Zigbee Pro. Zigbee Pro has a more power consumption and it is relatively more expensive as compared to the Zigbee, but the Zigbee Pro is used more as compared to Zigbee. Okay, and if we compare the Zigbee series 1 with Zigbee series 2, then it is observed that the indoor range of the Zigbee series 1 is a 30 meter, while the Zigbee series 2 is have a indoor range of 40 meter, and the outdoor range of the Zigbee series 1 is 100 meter, and while the Zigbee series 2, the outdoor range is about 120 meter. That's why it is preferred more over the Zigbee series 1. And these are the Zigbee topology such as star topology, mesh topology, and tree topology. In case of the star topology, here the Zigbee devices nodes within the Zigbee networks, they cannot communicate directly, they can communicate via the Zigbee coordinator. Okay, in case of the mesh topology, each and every sensor node are connected directly with each other. That's why there is no network congestion or the traffic problem here. While in case of the tree network or topology, the Zigbee network nodes help other devices directly to connect to each other. Okay, if a node of the Zigbee devices keeps form a network by connecting multiple devices. Okay, and in case of the tree topology, it forms a grid-like structure. The topology that comes under the Zigbee, and the devices which has been used by the Zigbees are coordinator, router, and the end devices. Here, the coordinator stores the information about the network, and for the performance of the network, the coordinator node needs to be installed firstly, having the same PAN, that is personal area network ID, with respect to the router or the end. The node acts like a supervisor or the router devices. Here the router is path among the network, and they can get the connection with the basic or end devices. As other devices not work in the same network. If we talk about the end devices, then these devices can execute the transmission or reception as a message, but the routing function cannot possible by using the end devices. One of the advantage of using the end devices are that the sleep mode nature of the least power consumption. These end devices use more the Hello.
Yes, madam.
We can develop the WSN application easily. Okay, sir. Thank you so much, sir.
Okay, okay. Thank you.
If anyone has a question, they can ask.
Okay. Now the participants are requested, if you have any question regarding the terminologies or definitions, something like that, you can please carry on with your question. The madam will answer your queries. There is some bandwidth problem associated with the speaker. That's why we are unable to communicate them. Hello.
Hello.
Anybody having any question? Any student?
No, sir.
Okay. Yes, yes. Madam,
Okay.
Mujawar madam.
Yes, sir.
Ha. It was a nice lecture from you. And as we know, the area of modern communication is very vast. You cannot complete it in 1.5 hours. Time limitation is there. But within that time limit, you have given a very good touch to all the areas that are related to modern communication systems. So I am really thankful to you for giving us the valuable time and making us aware of what are the new technologies coming in the modern communication systems. Okay, I request Dr. Godke sir to please give the vote of thanks, and we shall conclude that session. Over to Dr. Godke.
Thank you, sir. Good afternoon to all. Respected President of today's second guest lecture on modern communication system, Professor Dr. Bharti Rewardkar, Principal of Sri Shivaji Mahavidyalaya, Barsi. Resource speaker of today's guest lecture, Dr. Mujawar T.H., Assistant Professor from School of Physical Sciences, Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. Professor Dr. T.N. Lokhande, Science Coordinator of Sri Shivaji Mahavidyalaya, Barsi. Professor S.S. Suryavanshi from School of Physical Sciences, Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. My colleagues, Dr. K.P. Deshmukh sir, Electronics Department, DBT Coordinator, Khardekar sir, teachers, participants, and students. It's really great that today's guest lecture on modern communication system is turned out to be very successful because total participants near about 40. I am here to present the vote of thanks to the participants who made this event successful. First of all, I would like to thank the President, Professor Dr. Bharti Rewardkar, Principal of our college, for encouragement, support, and taking efforts to make this event successful. I would like to thank today's speaker, Dr. Mujawar T.H., for giving informative and good guest lecture on modern communication system. The participants understand the basic concepts of modern communication systems. I am thankful to the guest lecture series organizing committee of our college, Dr. V.M. Gurme, DBT Coordinator, and Professor Dr. T.N. Lokhande, Science Coordinator of this college. I am thankful to Dr. T.N. Lokhande sir for participating on this guest lecture. I am thankful to Professor Dr. S.S. Suryanshi for participation in this guest lecture. I would like to thank to Kiran Kumar Khardekar sir, all the teachers, participants and students for their participation in this guest lecture series. I am thankful to Professor Dr. K.P. Deshmukh sir for giving nice introduction about the today's resource person, Dr. Mujawar T.H. Thank you all. So I hand over to Dr. K.P. Deshmukh sir. Please end the,
Thank you, sir.
okay,
Thank you. Thank you for the vote of thanks.
okay, thank you.
Thank you.
Now it's time to end the lecture now, because we have already crossed the time limit of 1 hour and 45 minutes. So with the permission of the resource person,
Yes, sir.
I would conclude this session.
Thank you, sir.
A very successful one and nice one to hear. Thank you, Mujawar madam.
Thank you so much, sir, for giving me this opportunity.
Okay, it's our pleasure. I thank all the participants also. They have taken active participation in the today's lecture. So I will end the meeting. Thank you all.